One of the best ways you can test your reflexes is with a reaction time test. If we break it down, we can figure out that the moment a trigger executes a function, a timer starts running and stops when it receives an input. For this project, I've used an industrial push button, a 132 by 64 OLED, male-to-male wires, a LED, a resistor, and the core is the Arduino Uno microcontroller. Using a soldering gun, I can solder the connection terminal to the wire. This project uses two important functions. Firstly, it is the debounce function, and second is a watchdog timer. For the debounce function, it deals with a common issue when using push buttons or switches with Arduino. A mechanical button doesn't make a clear on-off signal. So when you press or release it, the contacts physically bounce, creating many very fast on-off transitions within a few milliseconds. Without debouncing, your Arduino might think you pressed the button multiple times instead of once. Debounce fixes this by ensuring only one clean signal is registered for each press. Next is the watchdog timer, or also WDT. In Arduino and most microcontrollers, the watchdog timer is a special function that helps recover the system if the code ever gets stuck or it crashes. Here's what it does. The watchdog timer is like a countdown clock that runs in the background. And so your program must regularly reset or kick the watchdog to show that everything is working normally. And so if your program ever freezes and enters an infinite loop or stops responding and fails to reset the watchdog in time, the watchdog timer will literally automatically reset or reboot the Arduino. So in short, it's basically a safety feature that ensures your Arduino doesn't stay frozen forever. Now it's demo time. I'm gonna take my push button here and I'm gonna tell you how this code works. So firstly, it sends a starting introduction message. So let's reset the code and see it. So here, reaction test by Zachary, and then moves on to the next message. Press button to start. And so how this code works is, when I press the button, it sends a signal that I'm ready. And now randomly, between a certain time period, it will randomly turn on the LED. And so while this is happening, a timer will kick off. Now the moment I press this button again, it will stop the timer and display the stopwatch. Now let's try that. It says press button to start. I'm gonna press it, get ready, wait for light on, and okay, well, that was 457 milliseconds, quite slow, but that's basically how the code works. Let me try again. And a bit better this time, but usually the average reaction time is about 250 milliseconds, but because we're obviously using a button, it might take about 30 to 50 milliseconds slower. So let's try that one more time. And there we go, 247, that's a bit better. This program also has a function to see if there's a false start. So if I click it too early before the LED turns on, it will say that I've done a false start. So let me show you. If I press button to start and get ready, wait for light on, but I click it too early, it will say false start, try again. These type of buttons, they're very crucial for many different companies, and including interactive gaming venues. And these are the buttons you see all over the interactive gaming venues. This simple test can be very important and very useful for many different people. This project can be applied in helping seniors or those who are disabled to improve their MSK system, which includes the muscle flexion and extension behavior, the bone system movement, and the tendon strength.